Good afternoon, guys. Now, I'm going to make another video in relation to my last video. This is also in transit in Panama Canal, loading in New Orleans and transiting to Panama Canal. So there will be a drop restriction, and so let's start, guys. Okay, this will be from New Orleans to Panama Canal. And this is the question. The MV Panamax is a fix for a voyage from New Orleans to China via Panama Canal. So this vessel is going to China and transiting to Panama Canal. The maximum allowable drop at the canal is 12 meters, 12.0 meters. Okay. At present, water density of 0.996. So this is the density in Panama Canal. At loading berth in New Orleans, the density is 1.009, and the estimated consumption from New Orleans to Panama are the following. So these are the consumptions. Fuel oil tank number 5 center is 160.8 metric tons, and diesel oil DOT tank number 1 starboard is 10.5 metric tons. This is now the question. Find the trim required at departure, meaning departure at New Orleans from loading port to arrive Even Keel in Panama. So we have to arrive Even Keel in Panama. Find the drop at completion of loading. So it is also required that we have to find the drop of completion in New Orleans. Okay, so this is now the solution. So the maximum drop at destination, which is Panama Canal, is 12.04, and the density in Panama is 0.996, and what will be the displacement of 12.04? So we will check the displacement. The displacement is 70810.8. Okay, so this is displacement, and the LCB is negative 7.356. So take note of these two, and we will check this one. So the displacement is 708.08, and the displacement is negative 736. Okay, so this LCG or LCB, you bring it down in this column as your LCG. So put it down here. That's why you have the arrow. And with this drop, because this is salt water, so we have to convert it to this density, change of density. So with this displacement of 70810.8 multiplied by your local density in Panama of 0.996 over 1.025 constant, and the value would be this one, 68807.3. You multiply this displacement by the LCG, you will have the longitudinal moment, which is this one, and you put down the consumptions of your tanks. This is the fuel oil number 5, which is 160.8, and your diesel oil tank number 1 starboard will be 10.5, which is this one. Okay, and with the corresponding LCG, multiply the LCG with the weight, then this will be the longitudinal moment. And you add this one, mathematical computation, then you will reach the final longitudinal moment, which is negative 49.4886.19, and your total displacement here will be 6898.1.6. To get this LCG, you divide this longitudinal moment with the displacement. So, meaning negative 494886.19 divide the displacement of 6898.1.6, and the value you will get will be negative 7.174. So this will be the LCG. Okay. Now we will, since you have now this displacement of 68918.16, you will convert this to the density of in New Orleans, which is 1.009. So the formula would be displacement times 1.025 over the density of 1.009, and the value will be 68981.1 times your constant will be, this is the formula. The formula will be 6898.16, which is this one, multiplied by your displacement with the constant density 1.025 over the density in New Orleans, which is 1.009, and the value of displacement will be 7075.46. So this is the brackish water now, and with this displacement, how much will be his draft? So we'll check this one. Drop will be 70. The displacement is 70075.5. Check again. 7075.46. And what will be his drop here? A displacement. So it is a run up here. 70075.5. And the corresponding draft would be 11.924, which is this one. 11.924. Okay, and bring down the LCG of negative 7.174, which is this one, and the LCB. What is the LCB of this drop? So LCB is negative 7.43. Check. With this drop, what is the LCB? Is negative 7425. Negative 7425. We just round it to 3. And what is the MTC? Is 949.6. MTC is 949.6. Okay, and what is LCF is negative 0.80. LCF will be negative 0.799 or 80. Okay, so these are the values that we need for computation. Okay, now trim correction. Now you have to deduct the LCG from the LCB. So your LCG is negative 7.174, this one, and your LCB is negative 7.43430, and the value will be, resultant will be 0.256, which is your, what you call the, trimming arm. This is your trimming arm. This one, 0.26, and you got here is 0.256 or 26. Then with this trimming arm, multiply it with the displacement, which you have this one. So multiply it by displacement of 707.5, 70075, and the value would be 17939.31, which is called the trimming moment. With this trimming moment, you divide it with the MTC, which is this one, and divide it with 100, which is constant. So MTC is 949.6. So I put here 949.5, and your trim, final trim would be 0.1889. Final trim will be 0.189. And let's see, final trim is 0.188. Okay. This will be the final trim. Okay. Once you get the final trim, you have to compute for the change of the forward, because you have the final trim, so you have to compute the change of the forward, which is 1/2 LCB plus your LCF over LVP multiplied by trim. So what is your what is your what is your 1/2 of LVP? LVP is 215, meaning 107.5 plus your LCF, which is this one, over LVP is 215 times your trim, final trim, which is this one, and the value of change of forward drop will be 0.93, this one. And to get your change of drop up will be your trim minus your forward change of drop forward will be your change of drop up. Okay, so once you get your change of drop forward and change of drop up, you apply it to your initial drop, which is 1192, which is this one. Okay, so you apply the correction, forward correction, change of drop forward will be 0.93, which is this one, and up will be change of drop up will be 0.96. Then subtract this from forward drop, then you will have the departure drop of 11.82 forward, and up drop will be, you add this one, the up drop will be 12.016. Okay, check forward is 11.83. This one is 11.82, so almost 83, and up it with 12.016. 12.016, 12.019. Okay, so this will be your main drop, 11.925. Main drop would be that one, 11.925. Okay, so this is a manual computation, so just take note of these solutions from number 1 to number 13. Okay, and this is the formula for getting the final trim. This one, displacement times LCG minus LCB over MTC times 100. This is the one, guys. So the displacement, which is this one, 7009 707.546 times LCG. You deduct first LCG from LCB, then you will have the trimming arm. Once you get the trimming arm, multiply this one with the displacement, which is this one. Once you have uh, multiply the displacement, this will be your trimming moment. With your trimming moment, you divide it MTC, which is this one, then divide it with 100, then you will get a trim of 0.189. So this will be the formula for getting the final trim. Okay, this is the formula for getting the change of drop forward. So this is the manual computation, and we will check the by Excel. Okay, this will be your maximum permissible drop at Panama, and this will be your density at Panama. The displacement of 12.04 will be this one, 70811, and the LCB will be 7.36. This LCB, you place it here in this column to be your LCG. Okay, and with this density correction, you will have displacement of 688 68807.375, because this is the displacement of 12.04. So if you applying the density here, this will be your new displacement. Multiply with LCG, this will be longitudinal moment. Then you apply the consumption. The consumption is positive because you start from Panama going back to New Orleans, so you add the consumption instead of from New Orleans going to Panama, you subtract the consumption. But this one going back, so from Panama to New Orleans, so you add the consumption. That's why you have the positive consumption here. Okay, and your total displacement will be 689,817, and your total longitudinal moment will be this one. Divide this one with the displacement, and you will have your LCG of -7.170, which is this one. Okay, then you apply the density in New Orleans through with this displacement, then you will have a new displacement of 70075.54. This is the formula, guys, in getting this density. So F21, which is this one, displacement, multiply with the constant 1.025 over this local displacement in your range, which is G23. Okay, so this is how to get this value. This is the formula, guys. Then with this displacement, this will be the value of the draft with this displacement. Then you will get the LCG. Bring this down, LCG, and your LCB will be from this drop. You will get this LCB. Okay, check this one. 11.94 LCB will be negative 7.25. Okay, then your MTC will be this one. From this drop, you will get the MTC of 949,609. 949.609. And oh, I'm sorry, and your LCF will be negative 0.799. Okay, then this will be your trimming arm, and trimming arm will be H27. H27, that will be your LCG minus your LCB will be your trimming arm. Okay, and your trimming moment is this trimming arm multiply with this displacement, and you will have this trimming moment. Okay, and this is the required trim. So the required trim will be this formula. Required trim will be this formula: displacement times LCG minus LCB over MTC times 100, which is this one. And the value you will get is the final trim. Okay, then you compute this drop forward and drop up, which is this formula, which is this one. And you have to get first your change of drop forward, then you get the value of 0.093, and the value of change of drop up will be 0.96, which is this one. Okay, just to get this value of change of drop up is the final trim minus your forward change of drop forward will be your change of drop up. Okay, so that's it, guys. I hope you will like this computation. This is in the previous video, so I never use this one at this moment. We just concentrate at what is put here. Okay, so that's it, guys. I hope you will like this video, and if you like it, please click the like button, share, and subscribe. Thank you very much for watching, and have a good day.